All right, we have another question in the room. Go ahead.
Richard T. with the Post newspaper. A question for all of you. Out of the myriad of experiments that you conducted, both technologically speaking and medical, which ones, I guess, maybe resonated the most with you and maybe was the most meaningful to each of you?
I'll jump in. I've talked about it before, but I think one of the really cool things was the protein crystals, and part of it was because my last mission, it was kind of early on determining whether we could grow protein crystals on orbit. And then if you fast forward 6 years, we are growing lots of protein crystals on orbit and bringing them back to scientists who can use it. And one of the researchers told me this has accelerated Parkinson's research by years. And Keytruda, the drug Keytruda, this was another beneficiary of it, the space station research. And, you know, when you have friends and family who are impacted by cancer and they use Keytruda and you're going, holy cow, this would not have been possible 5 years ago. This treatment would not have been possible if you had been diagnosed 5 years ago. All of a sudden you get goosebumps and you're like, man, it's a really good thing that we have space station. So those two really stick out to me as pretty big underlines for the last 5 years.
Yeah, I think to piggyback on that, you know, the ring shear drop experiment that I explained earlier has very similar effects and very similar positive influence on both Earth and as we venture out into the universe. Then one of the other ones resonated for me because my alma mater had a part in it. So the Air Force Academy was working with rhodium and looking at tomato plants and how they react under microgravity in different areas of radiation. So they actually flew on the Fram mission as well to see, you know, higher up into the outside of the atmosphere what that radiation difference looks like on plants. And, you know, it's also important to look at plants and food as we continue to grow our distance that we move away from the Earth. You know, the resupply is going to be a huge problem that we have to solve along with food and water and reclamation. And so it's a small part of how we're going to get onto Mars eventually.
One of my favorite experiments is called the ELF, Electrostatic Levitation Furnace. And there are three reasons I like it. Because the first one is the Japanese experiment. And the second one is I majored in material science in my university. And the third one is so my first flight was in 2016, and I worked on the first initial checkout of that experiment, and it's kind of still working, and it had a lot of minor or major updates. So it's upgraded until now, and so I was really looking forward to working on that experiment again this time. And it was such a cool experiment that we can levitate a sample by using an electrostatic force. So instead of building a furnace with a heavy metal, and we can use a laser to heat it up until like 2,000 or 3,000 degrees Celsius to get a characteristics data at such high temperature. So it was very, very cool experiment that could be super beneficial to produce any kind of new materials on the ground.
If you enjoyed this video, consider supporting our effort to share the news in print and on our extensive website, and now on our new YouTube channel. Contact publisher David Day at area code 409-943-4265 to support the Post newspaper today.